Good morning or afternoon, listeners. Today we're here with George Dyche from Avery Dennison for the first in a series of Avery Dennison Labels and Labeling webinar series on RFID technology. Today, George will offer a presentation on RFID basics for the webinar that should last about 35 minutes. We'll be followed up by a Q&A session with George, but we do want this webinar to be interactive, so feel free to ask questions at any time during his presentation. On your computer screen, you should see a control panel. If that's not open, you can click that orange arrow and that should make it larger. Within that control panel, you can see a box to ask questions, and you can do so at any time throughout the presentation. Also, on your control panel, you should see a white paper from Avery Dennison's RFID experts available for download. The white paper will instruct you how to integrate RFID into your label conversion process. And finally, once the RFID webinar has concluded, you'll be able to listen again at labelsandlabeling.com. So now that that housekeeping is out of the way, let me introduce you to George. George Dyche leads the development of the Avery Dennison RFID division's UHF, HF, and NFC media products. He joined Avery Dennison in 2004 as a senior RFID engineer, and he was instrumental in crafting the test capabilities at the company's RFID Technical Center. George holds a bachelor's degree in science in electrical engineering from Texas A&M University and a master's of business administration from the University of Phoenix. His 20 years of experience in the wireless industry spans various technologies, including Avery Dennison RFID, fixed point-to-point microwave systems at Alcatel-Lucent, and surfaced acoustic wave devices at RF Monolithics. Hi, George. Thank you for being here today.
Hi, Chelsea, and thank you. And good morning, good afternoon, everyone. And I'm really excited about spending the next 45, 50 minutes with you, giving you a really good overview of RFID basics. For those of you who may know me or have had interactions with me in the past, my style is, I use an educational style for presenting, and we have a lot of material to cover in this short amount of time. And the way we've broken this presentation out is into 4 modules. So it's organized in a way that we'll go through each module. We will take probably 1 or 2 questions throughout each of those modules, and then we'll have time at the end for additional. This is interactive, so we do have some poll questions. I want to warn you now that you'll be required to have to click some buttons on your screen. Hopefully, you'll enjoy what we have for you today. So let's go through the topics real quick. So the first module, we will cover RFID fundamentals. There we'll talk about, what is RFID, how does it work, what are some of the components that make up the devices. We'll go through some RFID standards. The purpose of that is to give you an idea of what are the standards that you'll hear in the industry, where can you go for more information. And then module 3, which is my favorite, I've identified 5 universal jobs of what an RFID label has to deliver to the application. And through that lens of those 5 universal jobs, what I've discovered over the past 15 years is that irrespective of what the application is, whether it's a work in process or apparel item level tagging, the job that the tag has to deliver is the same. So I'm going to give you a unique perspective on how to look at that, which will help you frame up your perspective on applications that you're engaging and help you come up with some solutions. And then we'll conclude with module 4. We'll cover some common RFID terminology that you'll see and experience in your journey with the technology. Invariably, you will encounter an RFID expert either within your own company, with the customers that you are working closely with, or your technology partners. You need to be able to understand and listen to their listen and interpret what they're saying. So with that, let's go ahead and jump into RFID fundamentals. So the first question that we want to pose to all of you is, how many years have you been working with RFID technology? Your options are less than 2 years, 2 to 5 years, 5 to 10, and greater than 10 years. And we'll give you about 10 seconds to answer the question. And what's interesting here, the reason I want to know who the audience is that if you're new to RFID technology, it's a very exciting technology to be working with. There's a lot of growth in the industry, and so this presentation will help kind of keep you grounded. If you've been in it for more than 10 years and you're a veteran, you have the scars and bumps and bruises like I do, this presentation will also give you a unique perspective, maybe different than what you've experienced in the past.
Okay, and someone's asking if we are new, what to select. Did you say less than 2 years for them?
If they're new, yes, less than 2 years if they're new.
Okay. All right. Well, George, it looks like majority of our listeners are new. I'd say 71% say less than 2 years, and then that's followed at 16% by 2 to 5 years. So most of the people are pretty new.
Excellent, excellent. So good. So really excited. Then this is a great presentation for you, and we'll go through this pretty quickly. Now, I say quickly, however, sorry, my screen is doing something funny here. For the less than 2 years and less than 5 years, the two modules we'll spend the time on are the RFID fundamentals and then what the 5 universal jobs of an RFID tag. So let's jump right in. So RFID basics. What is UHF passive RFID? So for those of you who are familiar with the label industry and applying labels and stickers to products, you're very familiar then with there's printed information, there's a printed barcode, there's human readable that's on a label. And typically today, that if you wanted to take inventory of products in your supply chain, the way you counted was you had to physically touch every single garment. You had to therefore look at every single label, barcode scan that label to do a manual or a physical count. It takes a long time, it's laborious, the accuracy level, it's not something you're going to do every 2 weeks or every week. It's something you typically do once or twice a year, which can become an expensive endeavor. So what you want to do is make that into an RFID product where you can wirelessly read the items that you have in your field of view. And the components of the RFID technology would be a unique antenna shape shown in the black outline and a microchip. And the microchip is the intelligence of the label. So taking a label and bringing the antenna and the microchip together allows you to create what we call an RFID label. So RFID stands for radio frequency identification. You can see where RFID acronym comes from at the top. And it's the wireless transfer non-line of sight from the label itself, the tag, to the reader device that you're using to scan the area. So this is fundamentally what UHF passive RFID is from a label perspective. Now, what you will hear in the industry, RFID itself is a broad term. So think of it as an umbrella, and there's different types of RFID technology that exist. So the 3 common ones that you will hear in the industry are passive, battery-assisted passive, and active. The passive tags, or what I just showed you on the previous slide, is that they are powered by a radio signal. There's no battery on the tag itself. So the tag being passive, it's sitting there asleep, quiet, until you use an RFID reader, which is the interrogator. It's sending out a signal broadcast in the field of view. The tags will absorb the energy and power up, and then they'll start the communication back to the reader by simply reflecting back energy to the tag. And we'll talk about later in the presentation some of the terms related to the energizing and then the communicating back to the reader. But for now, passive just means there's no battery, there is a microchip, and there's an antenna, just like I showed you. The other technology is battery-assisted passive. So these would be devices that might have higher logic built into the product. So what does that mean? It means that you are possibly taking temperature measurements or some kind of measurement of the stimulus of the environment. So you're using a battery to run microprocessor, to run some algorithm, to drive some sensor that's built into the product. And by doing so, it requires a battery. It's used for that logic. The way the tag communicates back to the reader, it simply reflects the energy that the reader is sending to it. So you might, in the early days, 15, 20 years ago, if you look at your toll tag on your automobile, some of those have batteries in them. Those batteries last 5 to 10 years. They're probably running some logic in there. So going through a toll system, that could be an example of a device that has a battery in it, or time temperature data logger.
Now, George, we have a question from the audience here about the battery. You did kind of mention it, how long the battery can last, but the listener is wondering what kind of battery do these use?
Some of them are I think the most common is the coin cell battery. We're also seeing in the market, printed batteries, some zinc-based type batteries that are rechargeable. So the battery itself could be a topic we could spend a whole hour on discussing. But the common thing we see is probably the coin cell. I do see trends around printed batteries, flexible type devices.
Okay. And then another question is, of the three, the passive, battery assisted passive, and active, what's the most commonly used?
So in the industry, so when you hear about RFID in the news, it is passive. That is the most common. Passive is your lowest cost of the three technologies. Active means you have batteries, more chips, microprocessor. An active tag would be, think of a shipyard. So you have these large containers, and you put an active tag on each of those containers because you're reading very long read ranges. And so in the middle of your shipyard, you might have a beacon tower that's basically listening for those tags. And you need the battery on those active tags to be able to send signal much greater distance. When you are looking at item level tracking, at the item level, so think of apparel, think of luggage bags, think of marathon runners, you're putting an RFID label on those products, which are passive. Because with passive, and I'll talk about this in a little bit, you will get some very good read ranges with passive technology, and that's why you see it in the supply chain. That's why you hear retailers talking about adopting it. And what it does, it actually puts a flashlight, if you will, on all those products in your supply chain. But you only are able to read the tag when you interrogate it with a handheld device. So the tags will sit quiet and be asleep until you wake them up with a reader device, and that's passive. And that's the most prompt. Go ahead.
I'm sorry, we do have a question on the read distance, so I'm assuming that you'll get to that in your presentation.
Yeah.
Okay.
Yeah, and I can comment on that now. Passive tags, so 15 years ago, a passive UHF RFID tag, probably in a free space environment, would read, I'll say, 12 to 15 feet. It was good, but it wasn't overcoming the physical properties of the product that you're tagging. So today, the same passive tag technology can read 30, 40 feet with the handheld devices and with the chips. So we've seen a trend over time that the readers used for passive technology have significantly improved in their ability to hear tags and to process the tag data coming back. And also the microchip vendors such as NXP and Impinj and EM Microelectronics, they've evolved in their microchip, their silicon, to actually become higher performance. So that's been a trend we see, like any technology, right? Things get higher performance, longer read range. Active, you can see at the bottom, those can read greater than 300 feet. So so RFID is an umbrella. It really depends on your application. But what we're going to really focus on in this presentation is around the passive tag technology, primarily because that's where we see a lot of the adoption in the market today.
Okay. And one more quick question before we move on. We've got lots of questions already, which is great. But are RF, HF, and UHF, are those all passive tags?
Yes, HF tags, NFC tags, UHF, those are passive, which actually is a great segue into the next slide.
Oh, great.
Okay, good. These are great questions, by the way, and please keep them coming. We will do our best within the time frame to answer as many questions as possible. And for those that we are not able to answer during the session, we'll reply back to you or get the answers to you very quickly. So great. So passive tags, again, no batteries. There are three types of passive that you'll hear in the industry. You'll hear LF, HF, and then UHF. And the thing to understand about it is LF operates at a very low frequency, so that's typically in the hundreds of kilohertz range. So what might you use that technology for? Probably the easiest example would be tagging your pets. So many pet owners put in a small little microchip in the back of the neck of the pet, and that's typically LF technology. We've seen in the early days where cattlemen would use some kind of LF technology to tag their cattle. There you would actually need a wand type device to read it. You'd almost have to physically touch let's say, the back of the dog's neck to be able to get that read distance. So it's almost a near touch scanning. You'll see that in access control as an example. The HF NFC operates at a 13.56 megahertz frequency. And we'll talk about what the difference is between HF and UHF here in a minute. But HF, think of it as the library books, right? So you have libraries books that you check in, check out. So usually at the pedestal where you're doing the check-in, check-out, there is an HF reader. Usually at your exit gates, not to be confused with EAS, electronic article surveillance, but within libraries you could have the reading of the books as you go in and out of the gate itself. NFC, same thing. It's a passive tag. It operates at a very similar frequency as HF. The difference between NFC and HF, think of HF now as a little bit longer read range, maybe up to a meter distance for like reading library books, pharmaceuticals, things of that nature. And NFC is sort of a near touch. It's almost like 1 inch distance. So the best example is using your phone, tapping an NFC tag. And then UHF, which operates in a 900 megahertz frequency band. So the HF and NFC is based on coupling technology. You have a reader coil that's sending energy in space, and you need the presence of the tag, the NFC or HF tag, in that inductive space of energy, and then there's a communication. It's like a transformer. You have a primary and a secondary, two coils close to each other that interact. That's what NFC and HF and NFC are like. UHF, I'm sending a signal into space. It's propagating. It's bouncing off objects. It's bouncing off ceilings. The RF signal will get absorbed by liquids. So it creates an interesting environment with which to read product. That's something that we've looked at over the years. But again, the long read ranges, typically 35 feet, say 5 meters to 10 meter type distances. You can tag a wide range of products from jewelry, healthcare, luggage, tires. And that read distance, and we'll talk about this, that read distance that you actually get after you tag the product is a function of several variables. And I'll identify what those are to help you understand what to be looking out for and thinking.
So George, maybe this will come up in that slide, but we have someone who asks, does the tag need line of sight, and do certain materials block the reading signal?
Okay, so the first question of line of sight, you do not need to have line of sight. If the tag is in the field of view of the product of the scanner, so let me give you an example. If you go in, for example everyone can understand, if you go into a retail store and you're looking at a wall of jeans folded in the little cubby holes, well, if I wanted to physically count using barcode, I'd have to touch every single item. RFID, I can take a scanner and just sort of wave it in that field of view. And as long as the energy is getting to the tag and the tag turns on and the reader can actually get its ID back, you do not need to touch the product itself. So it's non-line of sight. The label could be folded in between. Think of luggage where as the luggage is moving through the conveyor system, I don't need to read the barcode. I just need to make sure that the tag has energy and it's actually communicating back. Now, in terms of materials that can block RF, metal is a friend and foe. So with metal, if you had a metal container and you took an RFID label and stuck it directly on there, you will not read that tag very well at all, unless you can get some separation and distance off of the metal surface. And there are hard tags on the market by specialty converters and companies that specialize in making RFID tags for on-metal applications, like industrial, ruggedized, that kind of nature. Metal can also be your friend, where if metal is in the environment, so think of a metal shelf, perhaps, and because the energy is reflecting, you can get these locations in space where the energy is actually adding in phase. So there's a lot of energy. The tag can read even greater distance. And then the reverse can happen where the reflection in the environment creates a null. There's no energy at that physical point. And if a tag happens to be sitting in that spot, then the tag's not receiving any energy. So movement within, if you have metal, it can help you both ways. It can hurt you. but also, movement of, walking and scanning or product moving can help overcome some of those challenges. Great question, by the way.
Yeah, we've got lots of good ones in here, but
Good.
I think we'll get to them.
Okay, great. I love the questions. Keep them coming. This presentation is for all of you, and I'd like to make sure that your level of understanding is where it needs to be. So what we're going to focus. Oh, question?
Sorry, before we move on, sorry, because this one kind of directly relates to what we were just talking about.
Okay.
Is metal the only barrier, or are there others?
The other barrier could be, we've seen, leather material, any material that inherently can absorb RF energy. If you're applying a label directly to it, it can detune the tag. We'll typically test things on free space. We'll test it near metal at different distances. You can put these tags on plastic. Plastic tends to be a pretty good material that, in some cases, I don't know why, but it'll actually amplify the signal. So tags do like plastics. If you're tagging plastic totes, we see a lot of different inlay types that will work. Liquids are a big challenge. So if you think of a glass, well, this is great. So think of a glass and it's half full of liquid. You have two materials that are influencing you. Number one, the glass itself. So that has a very high dielectric. So if the tag is not tuned to exist with that type of material, it could detune the frequency. Your read range gets shorter. Move the tag down, so now you have glass plus liquid. You can get further detuning of the tag, and your read distance gets shorter. So the way we approach and how I look at things is I look at the product itself and try to understand what are the attributes of the product that I can control. Where can I place a tag? Where are the friendly and unfriendly areas? And then that product, and I'll talk about this later, that product by itself, maybe you can get a tag to read. But what happens when you put a cluster of those products? So using the glass analogy, you're tagging a single glass bottle, but now you put 6 or 12 in a case. That case gets put into a pallet, and you're trying to read at longer distances. So liquid and metal, you'll see the two most common things. Fiberglass, doesn't tend to be a big issue. So there's a wide range of materials. So the way you characterize materials, are they low dielectric? The lowest would be free space at the dielectric of 1. And then when you go to glass and other heavier absorbing materials, you'll see that it has an effect on the tag. And as a result, you have to design the tag for those applications. Great, thank you. Okay, so I think this slide does kind of summarize what we did talk about, but I think what I want to talk about here, the difference between LF, HF, and UHF, data rate of the communication is very fast within the UHF product category. Taking those 10,000 pair of jeans on a wall, for example, with UHF, it might take several hours to manually count. With RFID, you could probably read it in less than 20 minutes, 10 to 20 minutes, and get a very accurate count. The liquid and metal, UHF, the reason it's a little bit in the red bar here is because it always presents a challenge to UHF, but we've seen the chip technology evolve, our understanding of the materials and how we design the antennas have evolved, and reader infrastructure has evolved and improved significantly. So the thing to think about with UHF and passive technology is I need to get energy to the tag, and the tag needs to communicate back to the reader. And the variables that influence that are the materials of the product that you're tagging, the environment that you're in, the configuration of the product, and then even the type of reader device you're using. It could be a handheld, a portal, or an overhead. And I'll talk about that a little bit later. So what are the components of a passive tag? So again, this is an example of a dry inlay, and I'll just describe what the components are. So if you're a label converter, you're going to take an RFID inlay and you're going to make it into a label. So typically the RFID inlay is on some type of carrier. The most common in the industry is a PET substrate. We can put it on paper substrate or fabric substrate. Why fabric? Well, if you're going to make a sew and care label for apparel, that might be an interesting substrate to put it on. PET, again, is the most common. but you have to have a carrier. And then you have the integrated circuit. So this is the intelligence of the label. That circuit contains user memory, the amount of data that you can put in there. I'll talk about that shortly. And then the chip manufacturers, they, in addition to the memory, they also add special features and functionality into the chip for different application spaces. Looking back 10 years ago, each silicon manufacturer would come out with a new generation of silicon which had longer read distances. Probably in the last 3 to 4 years, we've seen more. We still see the improvement in sensitivity, read distance, but we're also seeing the chip family expand into additional EPC memory, additional user memory, additional functionality for, again, specific applications. So the availability of chip types in the market today is greater than it was 5 years ago. So it's really enabling us to create new inlays for applications. The third component of this is the antenna. What you'll see in the market, the most mature technology you'll see is aluminum. It's a very good conductor. The industry moved away from copper to aluminum, I think both from a cost basis perspective, but also from a performance. It performed very well. And the other thing that you'll notice is that no two inlays look alike. The antenna geometry is what creates the performance of the tag. It needs to exist with a particular dielectric material that you're putting it on, whether that be wood or leather or plastic. And that shape of the antenna is kind of like the behavior of the thing. If you remember your grandparents' old radio TV set where you had the rabbit ears, so what were the most common things, complaints that you'd have with those rabbit ears? Well, your picture was fuzzy. It wasn't receiving very well. So what were you doing? You would go up to the TV, you'd grab the rabbit ears, you'd start adjusting it. And by adjusting it, you tuned the antenna to receive the signal much cleaner, and you got a clear picture. Invariably, though, you became part of the antenna. So you were asked to stand on one foot, one hand up, look to the right, don't move because it's during the World Series, and this is the last pitch in the bottom of the inning, and the game's tied. So you're asked to stand there and become part of the antenna. So that's one of the things that's unique about UHF is that you'll see in the market a lot of geometries and different shapes, but it's on purpose, right? It's to create a level of performance needed. And with that, the metaphor that I use when I talk to people and educate about RFID is I think about these tags as human behavior. So what does that mean? So as humans, we're intelligent. We each have unique personalities. We have physical characteristics. We're tall, we're short. Our muscle mass structure is varies. There are different physical appearances. Assume we're all clothed, right? So you see people dressed. Sometimes you might see someone in a white T-shirt that's from the 1980s to someone who's dressed very fashionably going to a New York ballroom dance or something. But you put all those things together. So as individuals, right, you have a personality, you have physical attributes, you're intelligent. But depending on your setting and where you sit, your behavior may change, right? So think about your communication with a travel buddy. If you're in an airport trying to have a communication and the environment's very loud, what happens? You physically have to get closer to each other so you can communicate more effectively. Go step outside into a library, okay? You can actually get further distance away to communicate and hear each other. It's the same thing with RFID. With RFID, where does the intelligence come from? The integrated circuit. Where does the personality of these tags come from? It's the antenna geometry, those geometric shapes that you see. The physical characteristics, which is the size. Well, it's the size of the antenna. And what limits the size of the antenna is really the amount of space you have to work with. You convert them into label tags, and the behavior of those tags is what we characterize as the performance in the application. And I'll talk about that. So just doing a real quick of what's the difference between NFC and UHF. So there's two things I wanted to call out for each of those. With UHF, you'll see two antennas that I have here, a round and a rectangular. Fundamentally, you have a microchip, you have a loop structure in the middle, and then you have kind of meandering lines, which is the antenna. These are one-to-many. So going back to the denim wall example, I have one handheld reader, and I can read tens of thousands of tags as I walk through the store and take my inventory. right? That's what that is. When you look at NFC or HF, look at the example of look at the difference between the antennas. You have a coil, conductive coil, on the right-hand side versus a single loop. So when you look at NFC and you look at UHF, they might be the same physical size, but they actually have different attributes. They behave differently. They work at different frequency. The HF and NFC, we call it one-to-one. I'm reading. To read that one tag, I have to take the phone and tap it, right? When I read a second tag, I have to tap it. So those are some of the differences between NFC and UHF, both in how the antennas look, but also this one-to-many versus one-to-one. There are lots of applications you'll see in the market. So if you go into your local retail store, certain brands, look at the price tickets, look at some of the accessory items. Most likely they're using RFID technology for inventory purposes. Pharmaceutical, healthcare applications, many applications for this technology. Some few examples that maybe you don't know is RFID, but it's there. Coca-Cola Freestyle machines, that's an example where they're using RFID technology inside. So the experience that you have for a user is that when you press grape flavor, you do get grape, and so there's technology in there to help that experience to make sure that you get what you want. Video game figurines. This is the game where if you wanted to change characters in the middle of the game, you just buy the figurine, set it down on a little pedestal. That uses NFC inside to read the figurine data and automatically change the character on the screen. That's an interaction thing to make the gaming experience very positive. Then you also have, you travel airlines. Delta Airlines in the market has been public about using RFID technology for tagging the luggage. They use a wide range of technology, not just passive RFID, but it's an example of where it's being used today. Go into your local retail store, you'll see it in the price tickets. So the technology is being used, people just don't necessarily see it. But the experience you get is with the gaming. And the experience you get is that your luggage is there when you need it. The experience you get is that when you buy online and the retailer tells you, I have this many in stock, well, if they're using RFID technology, they have a very, very, very high confidence that if they told you online that there's two, there's probably two in the store, and they know it. And when you go into that store, it's there. So it really enriches and helps your lives in terms of how you deliver products and experiences to the customer. Okay, so that's it for Module 1. And like I said, this Module 1 and Module 3 is where we'll spend the majority of the time. We had a lot of great questions in that first module. So let me switch gears and talk a little bit, just a few minutes, about RFID standards, and we'll cover that, and then we'll move into the 5 universal jobs of RFID tags. So we have another poll question for you. This is the point where you need to wake up and maybe click one button or two. So the question I have is, do you know where to obtain information on RFID standards? Yes or no? And we'll give you 10 seconds or so to answer that. Now, RFID standards, while you're making your selection, the RFID standards, they'll describe a lot of things about the air interface between the microchip and the reader device. So if you're an OEM manufacturer, if you're making chips, if you're making readers, hardware, there are the air interface standards that you have to follow. There are standard bodies that will help educate you on technology specific to those use cases.
Okay. So 82%, the greater majority, said no, they don't know where to obtain information on the standards.
Okay, great. Good.
But I assume you can help them with that.
I will help you with that, yes. That's consistent with the majority of the people being new to RFID. So this is great. Excuse me. Okay, so where do standards come from? So on the right, you'll see, I think you'll hear and see these things in the industry. If you buy electronic products and you look at the back, you'll see the FCC logo, you'll see a CE logo. So the standards are developed by these specific organizations, and these organizations are broken down into national, regional, and global bodies. So in the case of UHF RFID, I think what you'll hear is Gen 2 UHF technology. There's an ISO standard. So with HF and NFC, you'll hear things like ISO 15693. I'll talk about that. Right? So those are global bodies that talk about what the standards are in terms of what the communication is between the devices, but also how are like the memory structures organized, and anyone that's making devices need to make sure that they're following the ISO certified. Okay, the industry-specific bodies: AIM Global, GS1, Automotive Industry Action Group, and Department of Defense. So whatever market you're playing in, or you're focused on, I shouldn't say playing, whatever market segment you're in, most likely you have industry-specific organizations that are promoting the use of technology, or promoting standards, if it's labeling guidelines, things of that nature. National, FCC, that's the around communication standards in the U.S. ETSI, that's communication standards in Europe. So a lot of standards I'll talk about, this is where they're kind of generated or coming from. For UHF RFID, it started out as probably most known as Gen 2 UHF RFID. So every time somebody wanted to talk about RFID, they would use that mouthful: Gen 2 UHF RFID. Okay, can I use this chip with that reader, or this reader type versus another reader type? Well, as long as they are Gen 2 compliant, the interoperability between different chips types, different readers, as long as they're Gen 2 compliant, they'll talk to each other. If you were 15 years ago, there were different classes of chips, which some were you could write once and read it many times. Others you could write multiple times, but also read it multiple times. And that was the difference between what was called Class 0, Class 0 Plus. And it required different chips, different hardware. So you didn't have that scalability. So today for UHF, just to kind of ground us here, there is an ISO 18063 standard that exists. The industry standard body that you want to go to would be GS1. So GS1 has various organizations in different countries. There are work groups, action groups that you can get involved in. There's a lot of education that does exist, on that site. And EPC stands for Electronic Product Code. So GS1 has a lot of standards around, what is the specification of the Gen 2 protocol? How does a reader communicate to a chip? What does a chip need to do in terms of timing and sequencing and things of that nature? If you're technical, you can get that information from the GS1 website. So it allows the cross-vendor compatibility. You can use these devices worldwide. So the same tag that I developed today that's used in North America, it can be used in Japan. It can be used in Europe as well. But the readers would be specific to those regions because they have to adhere to the standards bodies. So that's for UHF. What you're going to hear also is, instead of that mouthful of UHF Gen 2 protocol that's ISO 18006C compliant, you could think about it now as RAIN RFID. So RAIN RFID is an organization body that started, I want to say a few years ago. I don't want to give them disservice on the time frame, but it was started initially through Impinj and some industry partners. Avery Dennison is part of that as well. The member community of that has a lot of both end customer organizations, but also technology partners. So RAIN RFID, it's an alliance promoting the adoption of this UHF technology. So think about it this way. If you walk into your hotel, you're checking into your room, and the person at the desk says, hello, Mr. Jones, here is your Wi-Fi access username and password. They're not going to say to you, all right, here's your 802.11g or whatever the standard is that they're using. They're saying it's Wi-Fi. So instead of this Gen 2 protocol ISO 18006C, you'll hear it as RAIN RFID. RAIN RFID, it's really in that UHF passive technology. There are standards in there that talk about the communication. But it's a good organization that you should become familiar with. Go to their website, understand, they have a lot of materials and downloads and educational stuff to help you learn about RFID as well. Within HF, you'll hear things like ISO 14443. That tends to be what you hear for NFC, used for payments. The 15693 protocol, that's for libraries. And there are different chip types that'll make sure that they are ISO compliant. I know I'm moving through this quickly because I want to make sure we get to the 5 universal jobs of RFID tags. But the other organization you want to look for is the NFC Forum. The NFC Forum is really promoting the technology, and within that forum, you can see the ecosystem on the right. In particular for this group on this call, the education, and research, I think that'll be important for you. A lot of information about the technology, how does it work, and some of the industry standards that exist with it. So I know this was a very fast thing through the standards, but just flipping through, I just want you to understand GS1 is a great organization, RAIN RFID is a great organization, and then NFC Forum. Those are probably the 3 you want to take an initial look at, spend time on the websites, and get a lot of good information. Okay. Now just doing a quick time check, and we have 15 minutes. So I'm going to spend probably 10 minutes going through this universal jobs of RFID label. We'll touch on the technology terminology at the end, and then we might have some time for a few questions at the end. So Chelsea, unless you see some burning questions coming through, maybe we can hold off until the end.
Yeah, there's a lot of good questions that I think would be suited for the Q&A.
Okay, great. So I tend to talk a lot, but that's my nature of giving you guys more enriching information, so I hope you find it valuable. Third poll question is this: how would you rate your ability to select an RFID label for an application? Novice through expert. My assumption is, since many of you are new, you'll probably be in the novice or advanced beginner stage. So we'll give you about 5 seconds or so to answer that.
And you would be right, George. I would say 71% say novice, and then about 20 or so % say advanced beginner.
Okay, great. Very good. Okay, so let's go right into that. So these 5 universal jobs, this is my 15 years of experience boiling it down to what does a tag need to do, and what are the things you need to think about when selecting a tag for an application. So the 5 are optical information. This is the printable, human readable. There's a unique ID within the label. You have to attach it to a product. The product goes through its journey through the supply chain, and at the end of the life of the product, the tag sometimes will get removed or reused, or thrown away. So job 1 is printed information. So when you look at an application, you're going to tag a product. So the question is, how large is the existing non-RFID label that you have today? Right? How much packaging space do you have if you're adding RFID to it? How much human readable information do you need? Okay, those questions will tell you what your label size is, and that's the label size you have to put RFID in. Now, it's very important because the smaller the RFID tag, the shorter the read range. The larger the RFID tag, the greater and longer the read distance. So there is a inverse relationship between there is a relationship between the size. Big tag, long distance; small tag, short distance. So you need to understand what real estate do you have available. So sometimes that's driven by the packaging and the printed information. And then you look for what inlays will fit inside that label. Some may be a little bit larger, so you may have to make compromises on the packaging, perhaps, to get the level of performance that you're looking for, or there might be a new design that can be made that would fit in the packaging. So this is the starting point. The second job that the tag has to deliver is a unique identifier, and this is what the silicon chip will provide. So typically, if you think about it, what is the unique number? So 96 bits is what you're commonly going to hear in the industry. Of those 96 bits, the first 58 are typically allocated for the manufacturer, what type of item is it, and the UPC barcode information. The remaining 38 bits are essentially the unique serialized number. So going back to the denim jeans on the wall, we have 10,000 pair of jeans. They all have a barcode. Some of them have the same barcode because they're the same style, color, and size. But you have 10,000 unique individual numbers. And that's where the RFID has its power. It's non-line of sight, and I give a unique number to that product. So some of the questions you have to think about, is do you need additional memory? Are you a work in process where you want to store data on the tag as it moves from point A to point B, and you've done a job to the product? Maybe you want to store it on the tag. or do you need additional functionality? There are things like a counter built into the tag. So if you had a drink cup with an RFID tag put on it, walked up to a fountain dispenser, and every time you dispense, it reads the tag and actually decrements the counter in the tag. So where if you've only given that person 3 refills, you'd actually put a value of 3 in the tag, and every time it goes to the fountain, it would decrement, and when it got down to 0, the fountain drink would not dispense anymore for your customer. So there's other functionalities that are provided by the chip manufacturers in their products. So speaking of the chips, if I were to put every single chip type and all the features and benefits on this slide, it would probably be a font size 1. You'd never see it. But I broke it out into really 3 main areas. There's basic memory, what I call additional memory, and then security and even higher memory. The majority of what the market's using today is in the blue, the basic memory. So what you'll hear is, and I'm using a 96-bit electronic product code value. That 96 bits has my barcode plus unique serial number. Okay, there's typically some additional user memory that's available, and so there are some unique things you can do with that. So for example, if maybe you wanted to put a lot code or something in that user memory, but still have a unique number for that product, you can do that. If you're shipping stuff from, maybe store A versus store B versus store C, or, could be what you put in the user memory as, hey, this is where this tag originated from, but I still have a unique number. Okay, and then you have these additional features. So I would say for all of you, 96-bit EPC or 128-bit EPC is the most common thing you'll see on the market. It'll most likely work for every majority of application you're thinking about. But now again, you go into a little bit higher memory. You can see in the green there's more user memory. So if you think about electronics or automotive, it's not just a unique number. You might have to put a VIN number, maybe lot codes, other codes that are required to identify the product. So the silicon manufacturers provide us with a palette or portfolio of chip options. So my job then is make sure I have it on an antenna of the size that gives you the performance that you need. Then you have the very high security stuff. It's very, very higher memory. They might have an encryption engine built into the chip, which is good for certain applications around vehicle registration, things of that nature. But the bottom blue is what I would say you're going to see the majority of applications.
George, we have a quick question before we move on.
Sure.
What's the WIP?
WIP is work in process. If I'm making a refrigerator and it goes from station A to station B, maybe there's some action or data I want to put into the tag. So work in process is as a product is being made. Your physical product that you're making, whether it's a car, maybe it's a electronic device, tennis racket. It goes through its steps through the manufacturing process. That's called work in process.
Okay, thank you.
Thanks. Okay. Then the other thing you need to do is the optical information, which is the barcode, you need to encode it uniquely with the RFID. So there's different ways of doing that. There are RFID printers that will print the variable data on the label, but also encode the chip on that label to match the variable data you have on there. So tabletop printers are one way. There are applicators that can print, encode, and then dispense label onto product as it moves through maybe a distribution center. Different printer types that can handle types of paper, direct thermal transfer, where you can do some inline encoding as well. So this is not exhaustive of all the options, but it's just the point here I want to make is that when you're printing something on a label, you need to make sure that it is uniquely, that what you encode in the chip matches what you printed on there. And the devices that we have here, this one shown, can do a read verification before it exits the printer. But it's really important to make sure that the optical matches the unique, because when you're generating that label, you're going to be using that RFID non-line of sight, so you got to make sure that it is the product that you intended to be. The third job is how are you going to attach this RFID tag to the product? And I'm just showing you some examples of 4 ways. Most of the time it's an adhesive sticker, so you're applying it to the product. So on the left-hand side we show a corrugated box, but imagine if that was a fiberglass structure, a plastic tote, right? That tag is interacting in close proximity to material, so I need to make sure that the tag will deliver its read range performance for you. And if you look at, fasteners, tag could be dangling, could be sewn in, it could be embedded in the plastic. How the tag is attached to the product is something we look at, because that can affect how well it can be read or not. Is it moving in different orientations? What are some of the factors we have to consider for that? The interaction, this is the piece that's really important, is because this is a generic supply chain, and these are examples of all the different read points that you might want to read a product. So as a product moves through the supply chain, are you reading it just at its endpoint with a handheld device? But you might be reading it upstream, and your customer might be reading it downstream in a different way. So I really need to make sure we understand the product configuration, how you're reading it, to make sure that you get the right read range, right? So at all those different read points, you can use the same tag for successful reading. So the point is to not be isolated to just one type of application. It's where did the product come from, where is the product going, and will I interrogate it a different way, downstream or upstream? And that does have an influence on the type of tag that I would select. And the way you would look at that is this graph here, is this kind of conceptual map, which is I can use a handheld, a portal, overhead, conveyor reading, but you look at the product. Is it a single product, like a glass that I talked about previously? Is it now 6 or 12 glasses in a box that I put it into a carton of, now it's 24, now it's on a pallet? So at each of those intersection points, we look at what's the size of the label, how are you attaching it, what's the material of the product, and the configuration. Is it a product that is going to sit by itself, easily read, or is it going to be like pharmaceutical vials where there's many of them in close proximity to each other? That's the number of items and the density. And then your read success criteria. Are you trying to read 100% of what's in the box? Or maybe you've done an association to the carton label where you don't need to read 100%. You just need to read a few of the items and still get some association. And we also look at what type of hardware do you use. There are different types of handhelds. There are different types of portals. So all of those factors come together, and we look at it and say, this would be the tag that we'd recommend for your application. So what that all kind of boils down to is, you look at the antenna designs. The antennas are designed for a specific size for a specific application, but these tags are not limited to just that application. You can use a tag design for apparel in work in process, industrial applications, as long as it gives you that read range that you're looking for and it fits within the label that you have available for the space. So you can use these across globally. They're tuned a little bit differently, so the smaller ones will work differently than the large ones, as I said. And then you have the integrated circuit, which we match the chip to the size of the antenna to give you those special features that you would need. And then the last job that happens is the how easily can a tag be removed. Depends on the application. So what that means is you want a label that has enough strong enough adhesive to adhere to the product, stay on through its journey, but at the end of the life, maybe you want the label removed and not leave residue back or damage to the product. So just as you would look at your normal label applications, RFID is no different. You're applying this label, you're going to remove it at the end. You don't want to damage the product, and can the tag be reused? We've seen tags where they're embedded in a little plastic insert. That insert can be then removed off the tote, snapped in, and reassociated to the product at the beginning. So there's different ways of possibly reusing the tag. Now, I know I went through that very quickly, but I think what's important is these 5 jobs do not change irrespective of the application. Okay. Any questions? I'm sure there's a lot of questions.
Yeah, there's lots of questions, and some themes are emerging, so we'll handle those in the Q&A. But one quick question that someone wanted to clarity on one of the acronyms. What's EPC mean?
Okay, EPC is Electronic Product Code. So that's basically, yeah. So when you go, best example is go into your go into your retail store, go into like a Macy's, for example. They're very public about using RFID. Look at the price tickets, look at the barcode label, and look for a square, and it'll have the logo EPC. And that basically means that the product is using RFID technology. So that you'll see that logo used commonly.
I'm sorry, George. And then on that, what's the difference between EPC and user memory?
So the EPC is the unique identifier of the product. So the EPC will contain the UPC value of the item identifier, okay, like the barcode, and then a unique serial number. The user memory sits in a user memory bank that you can actually add. Maybe you want a timestamp. So let's say that you've read a product. Let's take a work in process example. You've got a product that went from point A to point B. In the manufacturing process, maybe you filled these vials, and you did that at a certain time. Well, you could generate a unique number based on the time and store that in the user memory. So when you read the EPC, which is a unique number, you can say, oh, I've read this vial. Then you can go into the user memory and say, oh, well, when did I fill this? You can use the user memory to put maybe a time, date stamp, maybe a lot code. It's kind of open to how you want to use it for your application. Okay. Great question. Okay, and I know we're running right at the edge of the time, and so we'll go through this here for a few minutes. Again, we'll take your questions. But the last poll question is, if you sat next to an RFID expert or engineer on a plane, would you be able to speak their language? If not on a plane, you'll get stuck with them in an elevator after your meeting. We'll give this about 10 seconds.
Okay, so we're about split here. We're about 49% say yes and 51 say not so sure.
Okay, good. So I'm assuming that the reason it's evenly split is because many of you are now educated based on this webinar, and so it probably skewed the data a little bit. So very good. Okay, well let's just go through what some of the common technical terminology, and I'll break it down into 4 areas. The air interface, the frequency, IC features, and inlay. So the air interface, the things we talked about previously, those are the EPC, Gen 2 protocol, ISO, RAIN. So you can see the logos at the bottom. So when you hear those industry bodies, standards, they are talking about the air interface between how a tag talks to the chip. Okay, so those are defined. Hardware manufacturers and chip vendors, they have to make sure that their devices work within those standards. You don't have to worry about that. You just need to know, in my RAIN RFID, my ISO 14443 with the hardware and chips, you'll be good. Frequency, these are the frequency bands of operation. So when you hear UHF, that is the frequency band of 860 to 960 megahertz. Within that band, FCC is North America, which is 902 to 928. ETSI is within that band, which is at 869 megahertz. But we've also seen recently where they're moving into the upper 900 megahertz band in Europe, which is good. NFC and HF, you just think it's 13.56 megahertz. Those are the frequencies that you'll hear associated with those terms. The IC features, which is the integrated circuit put on the chip. You'll hear it as known as a chip. It's known as an IC. It's known as an integrated circuit. But you'll hear the most common things you'll hear is EPC. So it was a great question earlier. That's the unique identifier memory bank that you have, 96 bits typically. User memory is additional space. You can store information on the chip if you'd like. TID is tag identifier. So each of the chips have a manufacturer code. So a lot of times that's serialized itself. But the main thing is the TID header tells you what chip type it is, what model number it is from the chip vendor. And the other thing is you can lock these tags. So after you've programmed it, you can send an access password. You can lock the chip so nobody can unlock it and then change the ID value. So you typically load an access password, and you can only unlock it if you have that. And then the kill command simply says, okay, I've read the tag. I don't want you to be read anymore. So electronically, you have to unlock it, and you kill the tag, and that means that it's not readable by anyone or any device, and you can't recover that typically. And the last thing is the inlay. So the inlay, the tag itself, you hear sensitivity. Sensitivity just means it's synonymous with read range. The higher sensitive a tag is, it means it's longer read range. That means I can deliver energy to the tag pretty easily. Backscatter is a term you'll hear, which is the tag communication back to the reader. Is it whispering or is it screaming? We talked about materials influence, great questions earlier. That's the dielectric properties. Does material absorb or reflect RF? Shadowing is a term you hear, tags overlapping each other. So tags in close proximity can impact the readability of that. And probably the last two you'll hear is dual dipole, which is synonymous with orientation and sensitive. There are some designs we have in the antenna where you can read it in any and all orientations. So that's great when you don't know the orientation of the product as it's moving through the supply chain or at the read point, and you want to get as much readability as you can. So that's a different class of antennas. And a dipole just simply means if you were to draw the radiation pattern of the antenna, it would look like a donut or figure 8. So if you try to read the tags on the end, so if you see my cursor here, if I was trying to read on this end, the read distance is much shorter than if you were reading along on the long edge itself. Okay, so these are just some common terms that we talked about throughout this webinar. These are common terms that you will hear in the industry as you embark on your journey of learning, applying. And the best way to learn this is get into a project, and there's nothing better than action learning, getting your hands dirty with the technology, talking to us, talking to your customers, and really learning. It's best by doing. So I actually had these broken out into, which we don't have time for, but I did go through what they are. And I think this is also in the white paper that we have available for download. And if it's not, I'd be happy to send you portions of this information. So with that, I know we're a little bit over time, so I appreciate everyone hanging on. I think any one of these topics we could have drilled down into its own webinar for an hour. So definitely would like feedback, if there are specific topics that you feel would benefit you on an area that maybe we can set up another webinar for future topics. But with that, let me turn over to you, Chelsea.
Sure, yeah, and we do have loads of questions, and I don't know that we'll be able to get to all of them, but there's a couple that I really liked from some of our label converters and how when they when they put this into practice, what type of equipment is needed to insert RFID into a flexographic label press? Excuse me.
There's different manufacturers. So Mobauer, Tamrac, Delta, those are manufacturers of label application. So you can do conversion two ways. One, you can laminate. So you can just take a web of inlays and laminate it to the paper, bring in your transfer tape, die cut, and strip. So Tamrac is one machine you can use. The other ways we've seen it, people actually will put an applicator in line. So you're running first your paper face, and you're using wet inlays to use with an applicator. You're just dispensing the RFID onto the paper face, and then you follow up with your transfer tape and die cut and strip. So I think that is in the, correct me if I'm wrong, Chelsea, but I think that is in the third webinar series, right? That's the third one, which I think is on converting.
Yes. Okay.
So great question. We have a webinar coming up on that.
And then another question was about the blocks. We had a couple of these. Will the RFID be the signal be blocked if you're using a metallic polyester label or any kind of metallized materials?
Yeah. So metallized, metallic-like properties, that's in the label face will detune the antenna. So what we've done is we actually use on some of our apparel hang tags. You can put like foil, embellishment on the tag itself. So you can put some on there, some metallic properties on the label. If you're doing a full coverage on the label, it will impact readability. What we look at is we can do the testing to determine to what degree. So there usually is some impact, but if you can compensate and put it near or away from the antenna that's underneath the label, you can overcome some of that. If it's affecting the inlay a little bit, but doesn't have any major impact in how the customer is going to read in the application, it may be a don't care. But generally, I would say yes. If you have metallic properties, in that label, it can interfere. But we just typically we measure and study what that effect is.
Okay. And a lot of people are asking about the cost range for the chips.
Well, we don't talk about so from a cost range perspective. I won't give absolute, but if you take from the very basic, typically it's less than a factor of 2, I would say. When you start adding memory, when you get into the really high memory, it becomes a much higher cost. So, labels, depending on the market, volume, size, RFID labels could be, below 20 cents, below 15 cents, in some applications, depending on what you are converting, what materials you're using. There's a range of the labels we see on the market, but the chips themselves, yeah, there is a difference in the higher memory. But how it translates itself into the label cost, it may be minimal depending on what level of memory you're adding.
Okay. And then one last question. We have lots, and we've already gone over time, but I just think this is a good one. But do you envision RFID being used in online shopping, and sort of vendors like Amazon?
Well, the omni-channel. So the way it's being used online in general is, this is interesting. If a retailer, let's say you're selling online, and your inventory accuracy you're not comfortable with, and if you have a requirement to keep 4 items safety stock, but you actually have 5, you're going to display to the online user that you only have 1. But with RFID, there are some customers that are opening up their inventory to the last item, to the SKU level, to display that online. So what's actually happening is the brick and mortar companies are using RFID to help with their omni-channel strategy. So we see RFID as a tool to help enable the online omni-channel strategy that retailers, brick and mortar companies are using.
Okay. Well, great. George, thank you so much for sharing your expertise today. That concludes our webinar. I know a lot of people had questions about how they can get the presentation, and I suggest that they contact you at your email to get a copy of the presentation or to ask further questions. And also, in your email, for those still listening, you will receive a survey. So if you could kindly take a minute to just complete the quick survey, it'll help us to know, to continue to bring you top-notch content like George's presentation today. And also, we kind of touched on there'll be a few more webinars from Avery Dennison and Labels and Labeling in the future. In the next coming months, we'll be presenting on the RFID segment, why it represents an enormous opportunity, as well as developing a successful RFID strategy. Thank you so much for listening, and again, have a great day. Thanks, George.
Thank you, Chelsea, and thank you everyone for listening. Really enjoyed the time.